We are talking about gerrymandering. We're going to get down to some amount of business today, but I actually had a little bit of show and tell of real life, maps that are in use. But I will just remind you of the basic idea behind gerrymandering. This is for electing representatives from geographical districts. For example, the state of Connecticut has 5 districts for the United States House of Representatives, and they're based geographically. Our representative is Mr. Jim Himes. The basic idea behind this, though, is that when you're electing representatives from geographical districts, where you draw the lines of the districts matters a lot. I will say where you draw the district borders matters a lot. And if you're allowed to decide where the lines go, you can influence the outcomes without ever even convincing more people to vote for you or anything like this. This can completely replace ordinary politics. Rather than doing stuff that makes people want you to win, you can just redraw the lines to make yourself win. So where you draw the district borders matters a lot, and when people sort of game the lines in order to win, this is called gerrymandering. And I think basically everybody thinks that this is bad for society. This is, in my opinion, undemocratic, and I'm not sure this is a controversial opinion. If you are winning elections not by convincing people to vote for you, but just by rearranging the lines in a certain way, this is undemocratic. But people still do it, and as with many things in American politics, the idea is kind of it's not great, but what are you going to do? It's just part of how our system works. One thing that you could say, what are you going to do? One way to I guess, end the problem is just say, we're going to set the lines once and for all, and we're never going to redraw the lines. And sort of somehow agree to make the lines fair once, and then make it illegal for anybody to change the lines. Actually, there's a major problem with this approach. Anybody, if you know a little something about American politics, how it works, that actually it's not possible to make the lines once and leave them that way forever. Anybody have an idea why this actually wouldn't work? This is kind of how the borders of the 50 states work. Nobody's trying to move the borders of the 50 states, although you could do something like that. But that's not allowed. I mean, you'd have to change the Constitution, I think, to move the state borders. But there are reasons why you cannot just leave these the same all the time, and that's because the number of representatives changes with population. Like we saw last time, California went from, I don't remember, but it was California went from 53 to 54 from one election to another. Now, if you go from 53 to 54, that means you must redraw the lines where it used to be divided into 53 regions. Now you have to change it so it's 54 now. And this actually happens all the time. So the sort of bad news as far as this goes is, I will just say this parenthetically, the lines must be redrawn every so often because of changing population. The lines must be redrawn when the populations shift. And so you can't just draw the lines once and leave them that way forever. And what that means is every time the population shifts, whichever goons are in charge at that moment will just change the lines in a way which benefits their party. So if the Republicans are in charge of the state, they will draw the lines in a way which is favorable to themselves. If the Democrats are in charge, they will draw the lines in a way which is favorable to themselves. That's the bad scenario, at least. Now, it doesn't always happen that way, but that's a problem with gerrymandering in our current society. I thought I got a few pictures, real life maps to show you just to see how this works out in practice. So the first one, cast your eyes to my screen. I thought about like printing these out for everybody, but I don't think it's necessary. If you want to look at these some more, you can, I'm recording this, so these will be part of the notes when I post them. Okay, this is the original, the OG, as the kids say, gerrymander. There was this guy named, I think his name was pronounced Gary, but he was some kind of congressman, I think, in the state of Massachusetts in 1812. And he was the first person that, is sort of, history says at least, he was the first person in the United States to realize that you could win elections just by redrawing the districts. And Gary redrew the districts in the state of Massachusetts. And one of the districts that he drew was this red thing here, which is a very strange shape. At that time, people made the hilarious joke that this shape was so weird looking, it looked like a salamander, and Mr. Gary drew it, and so they called it the gerrymander. Isn't that hilarious? That's where this strange word comes from. It comes from this guy's name, and the fact that this particular district that he proposed, I guess, looks like a salamander. It doesn't relate to me, but anyway, people at the time thought that this was absurd to have such a weird-looking district, and they thought he must be up to something, and he was up to something. He drew this weird district in such a way that it would make his party win more districts for using that. Nowadays, of course, that would not be regarded as all that weird. People nowadays, using computers or whatever, they draw truly ridiculous shapes on the maps, and it's more or less commonplace now. Although, like I said, pretty much everybody believes that this is not really a good thing that people do this, but people do it anyway. What are you going to do, right? That's what they say, at least. Anyway, here's a more modern map. This is in the great state of Texas, and you can see. So in this map, the red ones represent districts which have where the Republicans win those districts, and the blue ones are districts where the Democrats win. And you will notice the blue ones tend to be concentrated in the cities. That's because it is a fact in the United States, people who live in cities are more likely to vote Democrat, and people who live in the country are more likely to vote for Republicans. And so it's not a surprise that the Democrats, this is inside Texas, the Democrats in Texas tend to live in the cities, and the Republicans tend to live everywhere else. This is true everywhere, not only in Texas. All right. What's kind of interesting about this, though, I would like to zoom in on. So we see San Antonio and Austin have sort of Democratic areas here. Really, though, I think Austin is very interesting. By the way, I should say this is kind of an old map, not super old, but I know the map has been changed since this. This was like 3 or 4 years ago, and in Texas they change the maps often. But anyway, Austin as a city, if Austin is sort of like roughly around here, actually there are Democrat majorities all across Austin, although these districts have been chosen in a way so that the Democrats are only able to win one of these districts. And you can kind of see this strategy here. What's done here is we have many districts which are like way out here in the country, and then they stretch and they sort of worm their way into Austin a little bit. All right, that means, for example, right here, there's probably a lot of Democrats who live here, but the Democrats who live here have been, I would say, in a kind of silly way, they have been included with these people over here as part of this district. So what the people who created this map, what they did was they said, oh, we got a bunch of Democrats here. Let's put them together with these, farmers out here. And once we put these Democrats together with all of these people, then that's enough for the Republicans to win. And then we put some of the Democrats who live here, they get included in this district. This district here also stretches into the city, and then we have this district here. Again, there are many Democrats living here, but we include them in this larger Republican district so that they won't win. Of course, we got to throw them a bone every so often, so there is one district which they actually allow for the Democrats to have a majority in. But you will notice they actually connected this one, which is in Austin, snakes down here all the way to San Antonio, all right? And what that means is some of the Democrats living down here, there are some Democrats living over here, but they do not get two separate Democrat districts. They are included in the same Democrat district. That means the Democrats only get to win one district, which includes some people from Austin and some people from San Antonio. Of course, they also have another district in San Antonio here. But you can see another one of these sort of worms from the country comes in here to occupy some of San Antonio. All right. This is a typical kind of situation, and there's a name for this in the gerrymandering business. This is referred to as cracking, where you have this region here, which is majority Democrat, but I break it up into like 5 or 6 other things, and most of those I can include in other Republican areas to make it so that the Democrats don't actually win all of those districts. They end up winning one in this case. All right. This is a typical strategy that they use for the gerrymandering. I got any thoughts about this? I think it's interesting, very strange. Like I said, I think it's kind of bogus that people do this, but people do it. Let's look. I wanted to look specifically at Houston. So Houston, to me, this looks a little bit more fair in the sense that you don't see a lot of these, like we have a big sort of country district out here, but it's not sort of like snaking into downtown Houston to try to pull away some of the votes. What I would like to, so like I said, this one to me looks a little bit more fair, although I would like to draw your attention specifically to this district here, which goes like this. So this is a kind of a crazy shape. How did they ever think of making that shape, right? That's all one district, right? Why does it have such a ridiculous shape? Anyone know the geography of Houston? The answer is, so that's a Republican district. This is the district, like I said, actually this is an old picture. It's changed a little bit since then. But this is a district that represented by Dan Crenshaw, who's a Republican. He's the guy with the eye patch. I don't know if you follow politics, you've probably seen this guy. He's a common, Fox News guest. Anyway, this Republican district, why is it shaped like that? I'm here to tell you, because that's where the white folks live. So here is another map of Houston. Come on now. Look at that. This is a map of Houston by racial backgrounds. And the blue is the white folks. There's a little, I don't know if I can scroll this whole thing at the same time. The blue are the white people. The yellow and the green are Latino and black people. And you can see this line has been, now I will not be convinced this is a coincidence. This line has been drawn to specifically avoid the black people and the Latino people, all right? Now, this is suspicious to me. This is, as my kids would say, a little sus. You could say this is this district has been purposefully drawn to be racially segregated. I mean, I think that's what's going on here. Is that a bad thing or a good thing? I think my gut reaction as a fine young American is that segregation is wrong and we shouldn't have racial segregation in our that's like my gut reaction to racial segregation is that's probably wrong. Is it wrong in this case? Again, I think probably it is, but it's a complicated thing because when I say this has been segregated, you have kept all the black people and the Hispanic people together, all right, and you kept all the white people together. there's something that seems wrong about that to me, but at the same time, I was just saying, like in this case, I was just saying how, to me, it is kind of wrong to take Austin and artificially divide it into a bunch of places, right? Like in a certain sense, it does make sense to say these lines, they should not like cut through the middle of defined communities, right? Like if there are a group of people who are in some sense similar to one another, then maybe you should put them all in the same district together. Like for example, it has been suggested many times that you need, if you have, say, a black community in Houston, it would not be fair to divide that black community into two districts and they would be absorbed into some, a larger white community or something. That also seems unfair. What are you going to do about this? The answer is, I don't know. It's super complicated, and it's not, like, to me, it's actually not clear if that really is wrong to draw the lines in this way. I mean, it's definitely complicated. So let me just say, gerrymandering, and if you do some reading about this, the politics of gerrymandering, I will say gerrymandering in the United States, it is done in an effort to win elections, all right? So people do this, is done to win elections. That's why people draw these lines in weird ways. To win, I wrote it twice, elections. But if you look just a little bit below the surface, I will say is very often done along racial lines. Right? This kind of situation where the line just happens to divide a bunch of black people from a bunch of white people. This is actually super common. Now, if you talk to the politicians, I think their response would be, oh no, I'm not trying to divide the races. I'm just trying to win the election, and it so happens that the white folk are usually Republicans and the black people are usually Democrats, and so it makes sense to divide them in this way. Are you dividing them because of their politics or because of their race, though? And it's impossible to know the answer to that question. You just have to kind of take people's word for it. So this becomes super controversial and very complicated. I think a lot of things in American society are like this, like the issue of race is underlying so many things that it can be tempting to just kind of like ignore that and say, oh, I'm a good white girl and I don't see color. And it's like, if you don't see color in certain situations, like sometimes you ought to see color. Like it's important. Race is important. And if you just deny that all the time, you are missing out on important things. Anybody got any thoughts about this? I'm not trying to say anything super controversial, but this is like very complicated, I would say. Yeah?
Okay, well, I'm from California.
Uh-huh.
I know that, like, at least, like, this weekend, like, there's, like, Prop 50, which, like, you can vote on. So it's, like, kind of also gerrymandering.
Yeah, right.
Is that also similar? Because I know, like, obviously, like, Texas, like, from the maps and examples has done it too.
Mm-hmm.
But I don't really, like, know a whole lot about which, like, communities are going to be, like, redistricted.
Yeah, right. Yeah, I also don't know the details of the redistricting, but there is, if you follow the news, there is like right now a big controversy about Texas has decided, the Republicans in charge of Texas have decided to redraw their maps in a way which makes the Republicans even more powerful when we have our next elections for the House, which will be next year. Yeah, 26. Because Texas is redrawing its maps, they will automatically get a few more Republicans and a few less Democrats in the House. And in response to this, like this has widely been viewed as unfair, monkeying with the maps, but also legal. So, like, what are you going to do? And in response to this, the governor of California said, well, if Texas is going to do that to advantage the Republicans, I'm going to change all the maps in California to give an advantage to the Democrats. And he kind of says, like, I know this is unfair, but I'm only doing this as a response to what is being done in Texas. And yeah, this is also very controversial. As from an abstract point of view, I kind of think that this is all wrong, and it's up to you to decide, like, is it justified to do something undemocratic, but you're trying to respond to somebody else who is doing something undemocratic? I don't know. To me, it's complicated. I'm not from California, so I don't know the details.
It's okay.
Are you able to vote in this
Yeah.
this thing?
Yeah. So I'm voting this weekend.
All right. Interesting. Yeah. Very strange. It's kind of like the real like party enthusiasts, the super Republican types. They will do whatever it takes for Republicans to win more elections, even if that means doing slightly undemocratic things. And then the Democrats in California have decided to respond in the same way, at least a lot of them. We're going to do this even if it's a little unfair, but we have to do it in order to protect against the similar attacks from the Republicans. Very complicated issues. Important though. But I have no easy answers to any of these questions. Any other thoughts? Or thank you for sharing your truth with us. Yeah. All right. Let's talk about. I want to talk some specifics about how this is done. So I have a little handout here. This is exciting. There's going to be a lot more handouts for this little section of the class. Now, we are not going to try to do this using real maps usually. What you see here will be a kind of abstract, fake version of a map. Mm-hmm. Mm-hmm. So what we have here, I intend for you to hold it this way, although I suppose it doesn't matter. These guys, and I have one of these. Come on. Come on. Where'd it go? Oh, it's up there. I don't want it up there. Okay. So this here is meant to represent a map. This is a very abstract version of a map of people. Let's say each little square here is like a person, living in a grid somehow. They're living like on city blocks or something. Each square is a person. There are, if you count them up, there are 50 different squares here. There are 50 people. 5 by 10 grid here, and and they have these different colors. Now, as we're going to do a lot of examples like this, although I feel uncomfortable referring to these as the blacks and the whites. So let's call them the dark and the light people. All right, there's the dark shaded ones and the light shaded ones, and let's say that represents their political parties. So there, if you count them up, in this case there are 20 darks. I'm going to call those the D's, and 30 light. Those are the L's. You should imagine that these are like political parties, all right? Now, why are the people living in such a regular sort of grid? This is meant to be an abstract example. Of course, in real life, people don't live along a grid, and it's also, in real life, the political parties don't live like in columns like this, but this is meant to be a simplified example. And let's say we need to divide them into districts. Let's say we want to make 5 districts of 10 people each. All right? There are various different ways that we could draw these districts which would cause different outcomes to occur. And this is why I gave you so many copies of this same picture on the little handout there. We're going to look at several different ways that we could draw the lines which make various different outcomes. So one way to do this, maybe I'll, if I can, copy this guy here. One way to draw the lines one possible set of districts. I'm just going to make some lines here and see if you can draw the same ones as an example. I could say, okay, that's going to be one region. I'll call this one number 1. We could make another region here, number 2. You know, I'm just like pretending that I'm the guy in charge of drawing the boundary lines between these different districts. All right? Number 3, I'm gonna draw like this. You have to look closely to get it just the way that I get it, like that. Number 3. All right. Remember, we need 10 people in each. So I'm not just drawing these at random. I am trying to draw them specifically so that there are 10 people in each district, and you can count them up if you don't believe me. All right. Number 5, I'm gonna draw over here. Like that. This is number 5. And then number 4 is here. I hope you can see where my lines go. Maybe I should have used the red. I don't know. I hope you can see it okay. All right. This is just one way you could draw the lines. Of course, there are many ways you could draw the lines, but I'm just trying to talk about one specific example. All right. And then let's look at what are the outcomes. What's the results here? What I mean by that is like just inside each region, number 1, number 2, number 3, who wins when these people end up voting? They're going to vote for the dark or the lights. And I see in number 1, I see 4 darks and 6 lights. And so the light wins in district number 1. Maybe I'll put a little L right there. The light party wins in district number 1, right? What about number 2? Actually, number 2 is exactly the same arrangement of people in there. So in number 2, the L's are also going to win. Number 2 is exactly the same, right? Number 3, this is all very simple to do. You just count up inside number 3. It looks like we have 2 darks and 8 lights. And so the L wins again in number 3, right? In number 4, they are all light, and so the L will win in number 4. And they're all dark in number 5, so the D's will win in number 5. So let me just write that. Number 4 is 0 dark, 10 light, so L wins. And number 5 is 10 dark, 0 light, D wins. All right. So the overall result here, I hope everybody sees what I was doing. I was just counting up the various boxes inside each district. The overall result here, L won 4 districts and D wins 1 district, right? So overall, L wins 4 and D wins 1. This is the counts of districts won by, L versus D, right? 4 of them were won by the L's and 1 by the D's. All right? I would like for us all to try. I'll give you a few minutes, and maybe I'll walk around and see how you're doing. See if you can redraw the lines to lead to a different outcome. So in this, the way that I drew them here, the L's won 4 and the D's only won once. But could you have arranged them in a different way to get maybe the L's win 3 and the D's win 2? Or maybe the L's win all of them, the D's win none of them. Like maybe some of these are not even possible. But what kinds of outcomes can you get? So try, I'll give you a few moments, try to draw different districts leading to different outcomes. to be very specific about it, these are all of the outcomes that you could possibly get. And the one that I just did is this type, right? This one is possible, because that's the one that I just did. But could you get any of the other ones by drawing the lines differently? That's what I want you to try. For now, you should just be sort of like experimenting, but we will talk about real methods for this in a moment. I'll give you a few minutes. I'm going to walk around, see how you feel. Remember, every district that you draw needs to have 10 voters in it. There should be 5 groups of 10.
Yeah, that's what I'm trying to think.
Interesting. That's great. Anything interesting? Still going.
Is it okay if we have 6 left? What if there's a remaining left?
It means you didn't count them up right.
Okay.
You're supposed to have 5 groups of 10.
Okay, just 5.
If there's any left.
Oh, okay.
Yeah,
Oh, I
right.
did 6. That's right. Oh no, I did.
All right, let's talk about these because I wanted to say one thing before we go. But I see. Actually, let me make some more pictures for myself here.
You didn't need to have 5 districts, right?
5 districts of 10 people each. Yes, that's what I wanted to do every time. All right, can we talk about some examples? So as I was walking around, it's hard to describe in words what you drew, but I saw one person drew something like, maybe I'll put them, this is easier to see. How about there, here's one, a long skinny guy, like me, not as skinny as I once was. Like that, right? This is one, I don't know if anybody else drew exactly this, but this is one example where the results per district are pretty extreme. This is all D's. This is all D's, and then we have a L, and a L, all right? So this one, the result here is actually unanimous inside every district. This has 2 D's and 3 L's, all right? So that's another possible outcome, 2 D's and 3 L's. As far as my list of outcomes here, that's this one. This one is possible. That one also is possible. 4 and 1 is the one that I did. This one I saw from over here. 3 and 2. What about the one up top? 5 and 0. I saw a few people. Can anyone describe how to get 5 L's and 0 D's? It is possible to make the L's win every time.
Couldn't you just do what you did in the first one, the first example you did? You just did the first 10, the first 2 rows.
Yeah. If you just draw in this same way every time, you will see the L's going to win every time, right? In every district here, it's 6-4 with 6 L's and 4 D's. So this one is all L's. So this is 0 D's and 5 L's, right? Great. So that would be this this topmost outcome. Is the other one possible? 2 L's and 3 D's?
Yes.
Anybody? Yeah? You made one like that?
Yeah.
Can you describe what it looks like? I know it's hard to
That.
say in words.
I mean, like, I did the first 6 darks, and then I included 4, or yeah,
Like that, maybe?
Yeah. Or no, wait. I only included. I mean, yeah, that one.
I think this
Yeah,
will work.
yeah.
So let's take 6 Ds and 4 Ls there, and then I'm going to go down and take the next 6 Ds and also add in 4 Ls somehow, and then I'm going to take the next 6 Ds and add in 4 Ls, something like that. All right? And now you can see already we have D's winning there, and also there, right? So the D's are going to win 3 here, and I just have to divide the rest up however it works. There should be 10 in each, so if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I cut it off right here, I believe that's 10 in there. The L's win that one. And here, I think I did that right. The L's win that one.
Yeah.
All right, so here, the D's win 3 D's and 2 L's. All right, this is actually quite surprising of an outcome because in the population overall, there are more L's than D's. But actually, you can draw the lines in such a way that you get more D's than L's in the result. This is, in my opinion, like a totally unfair result, right? Because there are more L people than there are D people. But it is possible to get a lopsided result in the outcome. Very interesting and sinister if somebody was doing this in real life. But people do this in real life. All right. Is it possible 4D, 2L? Did anybody come up with, not 2, 4 and 1? Anybody make an example like that? Actually, it turns out this is impossible in this example. It's not possible. There simply are not enough D's in order to win 4 districts. So this is actually impossible. This can't be done. Get my thickness off. This can't be done in this example. All right. I would like to talk about why this can't be done. We got about 10 minutes left. That's what I want to talk about. How do you tell which outcomes are even possible in an example like this? So, and you will see one problem like this on the homework, if we can do it in the next 12 minutes. How to tell the possible outcomes. Right? It is a fact. In that example we were just talking about, it is not possible for the D's to win 4 districts, but it is possible for them to win 3 districts. How do you tell the possible outcomes? I would say you want to think of this, the important idea that you should focus on, the idea to concentrate on, is the threshold number of votes to win each district. All right. How many votes does it actually take to win one of those districts? Now, in our example that we were just doing, we had 5 districts, 10 voters each, right? That was my instructions to you, to make 5 districts having 10 voters each. And then we also had, just to refresh our memory, we had 20 total D's and 30 total L's, right? And the question I want to answer is just like, what are the possible outcomes that you could possibly make on this map in terms of how many the D's will win versus how many the L's will win? And I said the idea to concentrate is the threshold of votes which you need to win each district. In this case, the threshold, the thresh, is how many votes to win a district. Can anybody say? This is not all that complicated. Each district has 10 voters in it. How many do you win? How many do you need in order to win? 6. Yeah. If you got 5 votes, that would be a tie. I'm trying not to think about ties here. The threshold in this case is 6 votes to win a district. All right. It's always just however many total voters there are per district. It's half of that plus 1. if it was an even number. All right, so the threshold in this example is 6 votes to win a district. This actually is why I set up there, it is not possible for the D's to win 4. Can anybody explain why? Given this focus on the threshold, it's all about the threshold, really. It is not possible. Yeah.
If you need 6 votes to win a district, and for them to win 4 districts, they would need at least 24 total Ds.
That's
They only
right.
20.
Yeah. So you need 6 votes to win a district, and so that means in this example, to win 4 districts, we need at least, 6 times 4, which is 24, right? You would need at least 24 voters somewhere in order to win 4 districts. And the D's only have 20, so they cannot win 4. The D's have 20, so they can't win 4. And for the same reason, they certainly can't win 5, right? But I mean, there are 5 districts total, so like in theory, you should consider, can they win all 5? The answer is no, they cannot win all 5. Winning all 5 requires 6 times 5, which would be 30. And this is not possible for the D's. Is it possible for the L's to win all 5? Yeah, because they actually do have 30. And actually, I drew some example where they did, in fact, win all 5. So the D's have 20, so they can't win 4 or 5. But the L's have 30, so actually they can win any amount up to 5. Winning 5 districts would require 5 times 6 votes, which is exactly 30, and they do have 30, so they could actually make that happen, all right? So my sort of conclusion here, and actually you can do this, all this reasoning is done without looking at the map. You actually don't need to look at the grids. If I just tell you these numbers, you can figure all of this out without even looking at the arrangement of the numbers. All this is done without looking at the map. All right, so the possible outcomes in this example then, if I were to write them down, first of all, I would just write all possible, ways of dividing up the 5. I could go 5 L's and 0 D's. I could go 4 L's and 1 D. I could go 3 L and 2 D. I could go 2 and 3. I'm just writing every possible way that you could split up 5 total districts. I could go 1 and 4, or I could go 0 and 5, right? But because of what we just did, because of what we just said, some of these are impossible. If you look at what I set up here, sorry to scroll, right up the top, the D's have 20, so they cannot win 4 or 5, which means on this list down here, we can sort of X out those. Those are not possible. This is because we already said D's can't win 4 or 5, all right? I said it before. The L's could win any amount up to 5. That means all of these are possible, all right? The D's can win 3. They cannot win 4 or 5, but the L can win as much, any amount, and so those are all possible. All right. So this actually is our first, thing on the list under the gerrymandering topic is, I forget exactly how I said it. Something like determine possible outcomes. That's the first thing on the checklist. Is that what I said? Yes. Number 12 on the list. Determine possible outcomes. That's this. All right. I hope that this makes sense. You can do this actually without looking at the map. Now, the next item on the list, number 13, I suppose, is draw the possible outcomes. This is another thing entirely, but once you know which ones are possible, can you figure out how to actually draw them on the map? That's a separate matter, and we'll discuss that next time, I think. I guess that'll do for today then. Check out the homework.